Good afternoon. You can hear me, right?
Yeah, right now,
Yeah.
yes.
Yeah, okay.
Yeah, it's a bit problem with my headphones that I always supposed to choose the correct speakers on my laptop to hear you. So then I connect it again. So then let's start. So we were stopped on that slide, if I remember correctly, last week. So that firstly, I haven't received your emails from your group mails. So I don't know where to send the materials. So please write me from your group emails so I can distribute the Google folder and other materials. Okay.
Okay.
So then once again, so my email was here somewhere in the beginning. Yeah. So please use the Sergei email, which is with my surname and name. Yeah, the High School of Economics email will be activated probably this week, but I'm not sure. Okay, then let's continue. What's the- is it here? Okay, I'll start recording this time, so then I can upload it, and you can follow lectures once again. Maybe any questions before?
Not yet.
Okay, fine. Well, so we will start on some examples of platforms. If I remember, you named Facebook, Taxi, and some shops. Well, and we discussed these examples last week. So then let's move to what we're supposed to learn during the course. So firstly, some analysis about platforms, how they exist, how they need to understand them. So then how to divide the platforms between some monopoly and duopoly, how several platforms can exist together on the same market. So if they provide kind of the same product, like Android and Apple, and while we can observe both of them. So then we will concentrate on network effects. So that's mostly about how one agent which join the platform affects the other side, the other agents who are already connected to the platform. So and then we can think about such examples, right? Like why some services can provide you discounts and some sales to then you join on the platform. We have already discussed it a bit, I guess, last week. So then another crucial question is why the pricing of on the platform is not symmetric. Well, if you have two sides, then maybe you might think that yeah, it's irrelevant which size you are. You will pay the same fee. But in real life, And normally the prices are different from one side and from another side. And we will consider several models and understand why it may happen. So then finally we will discuss how to design the market to learn something about the consumers. So if you are talking about platforms like I don't know, some musical platforms or whatever else, then it's important for platform to know about the consumer, what he exactly wants from the platform to be suitable for a broad spectrum of agents or consumers. When what is important for platform is to know what exactly considered agent. So if you take one person and we know about him, so we can provide him some best product. But yeah, if you have broad spectrum of consumers, we need to know about them, their types, their preferences, yeah, and then we can operate better on the market. So it's just a now broad discussion, but then we will discuss it more precise. Yeah, and then you don't know about the consumers, their types, their preferences, then you can lose some profit, some potential profit. So then, as well, we will discuss some normative analysis, how to regulate the platforms and these two-sided markets. So that's about that's a bit connected to our discussion with about welfare theorems. So we talked last week that so if market exists, then there is already some outcome which gives you the situation, then no resources are wasted, let's say, or then you can say that it's somehow it's efficient, but then you start thinking, can we do better or not? So then that's probably what taxes do, and some taxation system, government rules, so they help to operate the market in better way. And in some terms, some goals which are set by a government. So then, if you are talking about monopoly, duopoly, so then we need to somehow think about, should we make some intervention if we consider only one platform operating on the market? And we will discuss this. So then, I think now we can switch to the definitions of the platform. So that's it about what we supposed to learn from the course. And let's start from definition of the platform and what we actually will consider in our course. So I asked you already last week, and someone said that it's something between two sides which cannot operate without. So that first definition on arrow, that's intermediate, who makes market or creates and help to exist the market itself, which gives the possibility to connect the buyers and sellers in some efficient way, so that without this intermediate it wouldn't be efficient at all or operates quite badly. But then we provide this intermediary, and this makes the market operate much, much more better. So then some examples could you provide? Then we consider, let's say, buyers and sellers.
For example, we can think of Russian platform Avito. So it is a middleman between sellers and buyers, and you can be a seller and a buyer at the same time. So without it, I think people would just, I don't know, gather somewhere on Yunnan or or somewhere there. So just outside, just in the street, and try to negotiate the price and something else. So it just provides the opportunity to do the same, but online. So it's much more convenient for both sides, and it also provides this opportunity for sides who don't live in the same city, for example. So
Great. So good example. Yeah, absolutely correct. One more question. So if you will consider Unona, for example, would it be the platform as well or not?
I well, it's some kind of the ancestor of the platforms, but yes, it's a platform.
Yeah, you're right. But so yeah, Unona can be a platform. So consider it as a platform because it's provide the space for sellers, the buyers can come, and so it's some infrastructure. But then what you mentioned, what was important is that Avito allow to connect the sellers and buyers between different cities without huge transaction cost. For example, if someone from Veliki Novgorod would like to come and sell something in St. Petersburg, so that the person needs to buy the ticket, so care about the stuff he want to bring to Unona and then sell it there. That will be quite expensive, so then which will increase the price for sure. But then on Avito online, you can sell it yeah, much more cheaper because you don't need to spend this transaction cost. Oh, so yeah, there are some other examples. So then we can consider another more broad definition, so that this is some intermediary who coordinates the demand of distinct groups of users who needs each other and facilitates economic or social exchange. So that's the definition, which is quite broad. And what is important is that you have several groups of users, so agents, and they want to interact. So it will be better for both sides to interact in some way. And you create this intermediary, which helps to operate more efficiently or coordinate them in better way. So then, yes, so all previous examples are in this definition as well. But can you provide some other examples?
Of platforms.
Yes, so the platform which is more suitable for the second definition, but not to the first. But if we are not talking about sellers and buyers, let's say, but about something else.
Well, we can think of the service, for example, headhunter. So they are not sellers and buyers, but the idea is the same. So one side provides, labor, and another hires. So basically, it's the same.
Not really, yeah, but the point is the coordination of, yeah. So then maybe Tinder will be a better example, right? So that you're not really buy and sell something there, or some marriage markets and another dating services, so that you can connect. So then you are not selling and buying something. So then we can talk about Facebook and Google News as well. So yeah, news are quite large market here as well. Then you're reading some news online. You don't need to pay for that. Yeah, especially so except the cases then you buy some premium subscription or something like that. So then, but anyway, in this market there are a lot of money cycling, and the studying of the structure of such a market is quite important. So then, what we need for several sided markets to operate. Yeah, the first the first necessary condition is that we need several different groups of users, which we need somehow to connect or coordinate. Yeah, because if it's just one group, then we come back to one-sided platforms, and that you will discuss probably during the principles of digital economy course, and we will actually consider one example as well. So what we need else is that if we will consider just exactly one agent on one side, and this agent would like to join the platform and increase some welfare, utility function, or whatever we are talking about, so that the agent would like to join the platform, and this will make him better off. So that there is some incentives to join, so that agent receive benefits from platform, other side, or whatever. And what else? What else does it mean is that if we come back to some examples, yeah, let's say Avito. When if you're a buyer and you're searching for some item, for example, if you would like to buy a used iPhone, then it's more better for you if you have a larger number of sellers of iPhones on the platform, on Avito. So if you will come and search for iPhone, whatever, 13 right now, in St. Petersburg, and you will find only 100 cases, then it's worse than if you will find 1,000, probably. So since your choice is broad, and you can choose better, it means that if one seller joins the platform, this we still make the other agents on other side, the sellers, better off, all of them, so that the high number of sellers increase the welfare of all number of buyers and other way. So if one buyer joins the Avito, so the all sellers on other side will benefit from this because they can find better match or sell something else to these buyers, and this the network effects. So then a little bit more about network effects, so that what I described right now, but in more precise definition, so that the agents who connected to the platform, his utility depends on the other agent's choice. So that if one more seller will decide to join the platform, this will increase the utility of the buyer. So then there could be direct and indirect network effects. What is the direct and indirect? So the direct effect is on your own side, and indirect effect is the effect on the other side of the market. So we will talk about this later, a bit more precise. So then indirect network effects will lead to a private gain of extra users from entering the platform. That means that so then one user of the platform and joins, this will lead to gains on the other side, and this will lead to gains on both sides probably as well. And this is not the social game. Well, and here is my question to you: why it's not equal to social gain? Well, let's consider the example that again, coming back to Avito, we have some agent, some buyer, or let's take seller better. So let's one seller joins the platform. We know that for buyers it will be better off, right? So that any buyer will be better. So, but why we cannot claim that this is the social gain and this is just how we make the market better off? Well, let me reformulate the question. So then, if one agent joins the platform, if there could be the negative effects, so the effect decrease someone's welfare.
Probably not.
That's not correct.
Maybe, well, if we are talking about buyers, so if one, well, oh, sorry, about sellers. Now, if one more seller enters the market, it increases competition, so other sellers can lose some profit.
Yes, that's the main negative effect. So that's yeah, if we are sellers or buyers, we increase the competition inside our groups. So if one buyer joins the platform, that means that maybe there will be not enough products for other buyers, or the other buyer will receive the worse match, so that I will join the market and buy the better iPhone because I firstly found it or whatever. So then for Fyodor it will be worse match and his iPhone will be worse than mine. Maybe even for higher price because I firstly buy the cheapest. So then let's say then when we push me to join the market, that if I'm a seller and I just maybe have some product, maybe not have, but someone that's a bad example actually. Okay, then let's talk about Tinder. For example, let's take Fyodor again. I think he's not against this example. So then if we will take Fyodor, and let's say Fyodor has a girlfriend already. So, and we will push him to join the Tinder. Probably it will make better off the girls on the Tinder, right? So that they can find the better match. Would you agree?
Yes.
But would Fyodor like to join the market?
No.
Yeah, probably if he already has a girlfriend, he don't need to join the market. It will decrease his welfare, or maybe his expectations about Tinder is not that good, so he wouldn't like. So then we have second negative effect, that then others can gain something from one more agent joining the market. This exact agent can be worse off. So that in total the effect can be still positive, but that's not equal to social gain because the person who joins the market could be worse off. And then we have these two negative effects. That firstly, that it's not necessary that the agent which join the market will be better off. And the second is that the competition will increase on that side. Yeah, in case if there is a competition itself, right? Because there could be the examples, then there is no competition in one side. Can you provide some actually examples? Then there is no competition on one side of the platform.
Well, we can just consider some vast platform. So if we increase the number of users in one side to like large amount, the effect of newcomer entering this market, it will be approximately zero.
There is probably almost no competition between buyers, for example. If there are a lot of products, a large amount of products, then buyers do not compete with each other probably too much.
Yeah, I wouldn't agree with first example. If there are still some competition, you have to, in the model at least, on some, it could be some slight effect, minimum, but you have to take it into account. But the example then it doesn't really exist. It's about Facebook. Then you join the platform and your welfare only gains from some other guy joining the market on other side. So you can talk or text with large amount of people. It's better for you, not worse. Or if we are talking about the streaming platforms, for example, music, Spotify, or there are some positive effects which are not strong, but mostly you just join and you choose between several compositors, so you can listen, but you don't really care about the others who listen. Yeah, there are some small effects, but generally no competition between listeners. So then let's move to the model. And today we will discuss the one-sided monopoly platform, which is the basic model. And then I will switch to the whiteboard to derive it with you and receive the results. So we will use this model on our exercise sessions. So what I have to do, I have to stop sharing. Oh. Okay, now you can see the whiteboard.
Yeah, so we can.
Wait. So I will later upload the notes to our folder as well. So then, so tell me then if it will be unvisible. So then let's take. So they have different consumers, and so we have the total mass of 1 consumers. That in other words, we have the interval of consumers from 0 to 1, and we can think about some consumer I who is living on this interval, and this consumer has his own type. Theta I. So this theta I will describe his preferences about platform and joining the platform. That's the type of the agent. So then what we need to have, so we will have price that the agent need to pay to join the platform, which is positive. So and when we have n, it's a number of consumers on the platform. And then that's probably enough to say what is the utility of the agent and how it depends on this parameter. So then if we are talking about the agent's utility, well, it will consist of two parts. Firstly, there will be utility, then the agent join the platform. So and this depends on his own type or own taste to the platform. It's, for example, how you like Facebook, or something more advanced we will talk later about. And this depends on the number of the consumers which are already on the market. So then if you join the Facebook, it will be important for you how much people you can connect there. And then you need to pay the price. So then we need to subscribe the price. So probably what we can say about, if we will take the drift with respect to n.
It's negative.
Well, why? So that's the number of users which are already on the platform, and
well, because consumers compete with each other. In some sense, maybe there is some capacity constraint, like I know servers become overloaded if there are too many people.
It's not like the club are good. I don't think that they really compete. The derivative should be positive because assuming that Facebook doesn't run out of service, out of their capacity, you just win something from any newcomer.
yeah, so since we're talking about one-sided platform, we are not about sellers and buyers. It's more about that Facebook of Kontakte. Then you have just platform and some consumers who can interact between each other. So if you are talking about one side platform by now, so then we're thinking about that it's profitable for consumer to join the platform because he will benefit from interacting with the same site because there is no second site right now. Yes. So that if you think about Facebook of Kontakte, it's a two-sided platforms, and we will talk about this later. But if we are not talking about the second side right now, only about the first one, so then we need to be increased because otherwise it will be really hard to think about how this platform would interact or exist, because if you have one consumer and you want to increase it with the second one, it will have negative effect on the first one, so he will probably would like to disjoin. So then let's think about how the platform and consumers interact. So since this is the model, we have to decide what's going on first, second, and third.
Excuse me.
Yes.
You switched off the camera. Maybe if you switch it on, it will be easier for us to follow. Well, it's just maybe it's my personal view, but still.
I'm not sure if I can do it during the casting.
Hmm.
I
Okay.
don't know. I can try, but no.
I thought that you are showing the screen from one account and like speaking and camera from another one. No.
So I can do this from when I'm doing for slides, but I need my laptop to cast the special because I need to draw on my laptop. That I can switch on it probably on the second. I can, but I'm not sure if you will see me.
Yes. Okay. If
Well,
yes, we
can
can
you
see you.
see?
Yes. Thank you.
Здесь можно вот, на секунду по организационным вопросам.
Да.
Мы вам прислали почту нашу групповую на почту вышки.
Ага. Вот, и у меня к ней пока нету доступа, я не знаю, когда она будет. Лучше продублировать на чешский.
Хорошо.
Вот. Да. Но я пока ничего не отсылал, потому что некуда, так что после этой лекции отправлю ссылочку на Google папку, где будут все материалы. Я пока не знаю, как запишется запись, потому что я первый раз использую эту программу, куда она вообще сохраняется и как. Вот. Но посмотрим, что получится. Так, okay, so you see me from here, probably. So I need to look down because I'm drawing here. So then, firstly, when the platform decide about P, so that then the second, observing the price, each consumer simultaneously decide to join or not. What is important in the model that they're doing this simultaneously, so then they don't do it sequentially. That's a bit different. So and third one, then the who decide to join then joins, who not decide not joins, and then we are in the equilibrium. So then maybe it's a bit difficult question, but still. So if you don't know, so that then consumer needs to decide if he would like to join the platform or not. The consumer doesn't know about the other's decision. They doing this simultaneously. So how normally in economics we think about such a problems?
As a Cournot kind of competition, we find the first order condition and find the best responses.
So then it's kind of what you will need to think about how the other will behave, right? Observing some information.
Yes.
So then let me a bit reformulate it. So then we need to think about, we don't know the number of the agents which will join the platform, but we can think about the expected number of the of the agents who will join the platform, and this, yeah, since so that's a number which will we expect will join, and from this knowledge we will think about should we join or not.
Excuse me. And so those steps are made one by one, but
Yes.
the consumers, they decide whether to join or not at once, right?
Yes. No,
Okay.
no. At second.
Yeah, I mean,
But simultaneously.
yes.
Yes.
Okay, thank you.
So that's why they need to build the expectations about how much agents will join the platform, because their own utility depends on this number. So, and what we know about the agents, so that we need to, so that we can build some expectations. Okay, the agents has their types, right? So that's probably we will have some types which like the platform, which dislike the platform, something like that. So then we know the types of the agents, so then we can build some expectations. So then let me talk about anything a bit more precise. So firstly, let's say that our type is uniformly distributed on 0, 1. So is it clear? What does it mean?
Yes.
Yes.
Okay, great. So that's they need some. We have 0, 1, and it's some line. It's a PDF, right? Right. It's a PDF of our distribution. So then, and then we need to specify our utility function. Yes, because we have it in general. Here we don't know what is U. So then let's think about different types. So firstly, let's think about, for example, so what we can say about this. And then we can divide it by two parts. Right. So the first one doesn't depend on number of the users on the platform. So how you can interpret this?
Like the utility I will get even if I'm the only user of the Facebook.
Yes, so that's kind of then you join your taste of just joining, so that you're okay. I have my page. There is some nice picture, whatever. And then the second part depends on the number of. So then, how they can think about this?
Like what utility would I get if n other users would join?
Yes, and this is network effects. Then you get in some utility, then someone else join, it's a network effect. And what we can say here, this depends on our type, right? So that different agents will have different taste to network effects. And that means that this model will be if, let me, heterogeneous network effects. So not because different consumers will receive the same utility alpha from just joining the platform. But if we are talking about network effects, this will be different for different agents. So then let me show you another utility. So we will yes, now it's a bit different. So now the network effect is the same for any agent, for any type, but we have different days to join the platform for different consumers.
Just to make sure, this symbol before the N year, it's new, right?
Yeah.
Okay.
So then in our model, let's pick someone utility. We will consider well, and I will make one assumption so that.
And can we imagine the model in which both elements depend on the type?
Yes, sure.
Okay.
Oh, yeah, why not? That will be the most close to reality, right? So then let's let's have such an assumption that so that nu is here is the coefficient between network effects, and c is the cost of so that's the platform's cost to join one agent. So then we will need it later. So then if we have such a utility function, how to think about who will join and who will not join the platform. Yeah, you remember that we have the a uniform distribution from 0 to 1. Right, so then there is some mass of consumers, so and who will join and who will not join the platform.
Those that will have positive utility from joining, the platform will join, and it will be, well, we can write an equation, an inequality to find who are they.
So let's say if I think about agent, right? So this the utility of the some agent, right? How I can distinguish the agents between who join and who is not?
Well, you should compare it to the utility of not joining. It is 0, right?
Yes, yeah, it's probably 0. So then I should think about if it's greater or equal than 0. And so if I have some mistake here or not. Yeah, you remember that we are deciding to join the platform or not. What we cannot observe.
N.
Yes, so then here they're supposed to put an expected, right? Well, then here is the second important question. Not the second. Another important question is how to think about an expected, right? So then we need to come back to some standard economical concepts. So, and we will use the rational expectations. So what is rational expectations?
Well, they are logical in some way.
They should be based on rational preferences.
No,
Yes, and yeah, it's kind of then, and I'm thinking about rational expectation. It's about risk neutrality and whatever profit maximization under risk neutrality, something like that. And are you familiar with Nash equilibrium?
Yes, of course.
So what is the definition?
It's the solution. It's the point from which it is not profitable. Well, no agent has incentives to deviate alone.
Exactly.
You can formulate it like no regret rule, meaning that nobody has regrets about their choice of strategy.
Yes, so that's fixing the other agent. So if you will fix all agents except one, so it's doesn't matter which one. For any agent, it's supposed to hold that there is no profitable deviation for this agent, fixing the other's behavior. So that what does it mean? It's mean that in Nash equilibrium, n expected is supposed to be equal to n in Nash equilibrium. Then like everyone think that those who join will join, and those who were expected to join will join, and so on. So that when we can think about, I'll come back to the question who will join or not. So once again, coming back to this picture, so how we can draw here who will join or not join the market.
It will be a straight line, and everybody who is above that line will join. We can find that line by moving price and other stuff to the right part of the inequality. It will be price minus mu times n.
Yeah, so that's let's say, so once again, can you hear me?
Yes.
I don't see the change on my video.
We can hear you.
Yeah, okay. So can you see the change on the picture with orange color?
Yes, we can.
So then there will be some agents who will join and who not. So and the agents with higher or lower theta will join.
With high, of course.
Yeah, so since utility is increasing in theta, so then this agent join the platform. Who is in between? That's denoted by theta I hat, and just theta hat. So which equation this guy satisfied?
Who joined?
No, who's indifferent, right?
Mm, it should be an equality.
So for this guy who is indifferent between joining and not to joining will be just equality, right?
Yes.
Well, then the next question. Then we know that if agent is with theta who is lower than theta bar, then this agent not join, right? And if agent is greater than theta hat, then joining. That's rational, right? So then in equilibrium, how much agents will join the market? So we know that these agents join the market. How we can calculate them?
We should just compute this square. Like
Yeah, and what is this?
1 minus estimate of data.
No, just theta. We can know this in different agent. So then, yeah, so that the agents who will join the market will be 1 minus theta hat, right? So yeah, generally it will be integration from theta hat to 1 of PDF, and then some integration. But if you have just uniform distribution, this 1 minus theta hat. So, and that's how the agent thinks about who will join the market and who will not. So then we can substitute it in our equation. And find and right. So then from here we can find theta hat. So the agent who is indifferent is 1 minus n, right? For this indifferent agent, we know that this inequality holds with equality. So then we can substitute it and write that 1 minus n plus mu n expected equals to price, right? If price goes to the other side. When from Nash equilibrium, we know that what is expected is supposed to be equal to what really happened. Right, so then we can substitute n expected with n. So then we can write that and this is our equation, which connect n and price. So what does it mean? So that we know that let me write it like that. So who can tell me what does it mean?
So the number of those who join is positively related to the price. It's strange.
So then that's not true. Let me repeat right. So since we know that mu is less than 1, so that's probably 1 minus p to 1 minus nu. Oh. No, just we have connection between n and price, right? So which tells us that if the platform will set some price, the platform knows how much agents will join the market, right? So then now what the platform knows? The platform has costs. C, you remember that we have 0, C, 1. It's just assumption. So then the platform knows the reaction of the agents on the price. So then we can choose price, right? Who can tell me how I should write the profit maximization problem for platform?
Well, it's price times the number of people who joined.
And then?
Then we take the first derivative.
No. Firstly, they need to subscribe the number multiply by costs of join the one agent. So C is the platform's costs of joining the one agent to platform. Okay.
We suppose that C so just multiplies, like no.
Yes, we assume that the costs are fixed, so that each additional agent costs for platform the same.
Okay.
So then we need to maximize this by choosing P. It was correctly mentioned that we need to take the first order conditions. So what we have here is an OP, right? Then it will be P minus C, and then this one, let me still revert it. So it will be yes, you agree? So then let me open line minus new and P minus C. Right, since we know that mu is less than 1, we can multiply by this. So then we have 1 minus 2 P plus C equals to 0, or that price equals to 1 minus C 1 plus C over 2. Right, and this is the price of monopolist. Correct.
Seems legit.
Huh?
Seems correct.
Okay, great. So then we need to calculate the number of number of users who will join the market, and this monopoly price. So that will be 1 minus 1/2 minus C over half, 1 minus nu. So that's 1/2 multiplied by 1 minus C, 1 minus nu. That's the second result. And what we know that C is greater than nu, right? So what we can claim about monopolist number of agents who join the platform?
It's not Pareto efficient.
Well, what does it mean Pareto efficient here?
Maybe is it less than 1?
Yes, it's less than 1. Even worse, it's less than 1/2, right?
Yes.
Because so that less than half join the market, and that's quite quite a result. So then actually our time ends. So then next time we will talk about probably social optimal. I'm not sure, maybe not. So what is the crucial points here? So the first one, to solve this, we need to think about the indifferent agent, right? So then we need to specify the utility function, and then we are thinking about the agent who is indifferent between joining and not joining the market. Then we can think about who is joining the market and who not, and think about expected number of agents who join the market. And then they need to rely on some expectation concepts, so that they need to think about Nash equilibrium, about rational expectations, and then we can only after that equalize these two expected number to that one which is in equilibrium. So then we're thinking about how our equation transformed to and solve it, and then we can do the profit maximization and receive the result. So then all these notes will be uploaded to a folder, and I will send you the slides with the results of the model, and so you can go through steps and see the crucial moments. Then you need to think about Nash equilibrium, and then you need to think about rational expectations. So then let me actually stop the demonstration.
So
yes, so you can see me again.
Does it mean that monopolist won't have a market at all? Like it's less than 1 user, so
no. We have the total mass of 1. So if we have 100 of them, they are from 0 to 1. So that was the uniform distribution just to describe. So that's, yeah, so from 100, it's less than 50 will join the market, because the rest wouldn't join the market at all. If monopolies, because the monopolist increase the price such that maximizing profits. Well, yeah, I'm not sure if there we will consider the. I think on our exercise session this Friday we will consider the social maximizing. So then let me stop the. Yeah, okay. I already have the the record on my laptop, so I will upload it for sure. Then, if you don't have any questions, that's it for today. We'll see you on Friday, but I'm here to answer your questions for a few minutes if you need. Yeah, don't forget to send me the email on my Sergei mail box.
Okay, thank you. Goodbye.
See you.